Hello and welcome. In this video, we'll talk about the laws of indices, and we're going to use the laws of indices in simplifying algebraic expressions. Now, we have already discussed the laws of indices in class, and this will just be a quick revision video. After going through the different laws of indices, we're going to use them in answering sample problems from a Corbetts math paper. So let's just start by recalling the different laws of indices that we learned in class. The first one is the product of power rule. Product of powers. Okay. So this is where we have, suppose, a base a raised to the index n multiplied by a raised to m. Okay. Now take note that this can be expressed as a raised to n times a raised to m. That would mean the same thing. It's multiplying. Or you can use a bracket instead. You can encounter a problem that uses a bracket as a symbol of multiplication. And we say that the answer to this is the same. So a raised to n times a raised to m is equal to a raised to n plus m. That's the same thing here. N plus m, a raised to n plus m. So when you're multiplying terms of the same base with it's terms with the same base with indices, you just copy the base and add the indices. Take note that indices are sometimes referred to as exponents in some texts. So let's use an example. So suppose we have a raised to 4 times a raised to 2. That is equal to a raised to 4 plus 2, which is a raised to 6. If we have more than one variable, suppose we have a raised to 2, b raised to 5 times a raised to 3, b raised to 2, okay? We work out, we apply the rule for individual variables, okay? So we just use the rules for a's and b's as well. So you don't combine the a's and the b's together. So you have a raised to 2 plus 3, because the indices of a are 2 and 3. And then b raised to 5 plus 2. So our final answer is going to be a raised to 5, b raised to 7. So you add the indices of a and the indices of b. So that's the product of powers. Now, the next rule that we need to revise is the quotient of powers. Take note that quotient is what we call the answer to a division problem. So if we have a raised to n divided by a raised to m, or it can be written as a fractional form, a raised to n divided by a raised to m, the answer to this is a raised to n minus m. A raised to n minus m. Now I will not dwell too much on the theoretical and mathematical proof of these rules. I would have reserved that for the actual classroom, but the purpose of this video is to make sure that you remember the different laws and you can apply them efficiently and effectively in answering questions. So again, when you have the same base with indices, okay, divided by each other, so a raised to n divided by a raised to m, the answer is a raised to n minus m. Okay, so it will become subtraction. So suppose you have a raised to 4 divided by a squared. The answer is a raised to 4 minus 2, which is a squared. If you have a raised to 6 divided by a cubed, okay, the answer is a raised to 6 minus 3, okay, which is a cubed. Okay, so it's 6 minus 3, not 6 divided by 3. If you have multiple variables involved, suppose you have, let's use different letters, so x raised to 4, y raised to 6, divided by x squared, y squared, okay? So it will become x raised to 4 minus 2, y raised to 6 minus 2. So the final answer is x squared, y raised to 4. Okay, now suppose we have an example where we have a numerical coefficient. Okay, so with numerical coefficient, just so we make sure that we covered all bases. So suppose we have a multiplication problem first. So you have 4a squared b cubed, okay, times 2a raised to 4 b raised to 5. So you do the multiplication normally with the numerical coefficients as if they're just numbers. I mean, they're really just numbers. So 4 times 2 is 8 raised to a, so 8a raised to 2 plus 4 is 6, and then b raised to 3 plus 5 is 8. So that's the final answer for that. Just want to show that the law applies even if you have numerical coefficients. If you have a division problem, suppose you have 16, let's use a raised to 5, b raised to 6 divided by 4, a squared b. So the answer to that is 16 divided by 4 is 4. A raised to 5 minus 2 is 3 raised to b. Now remember that there's an invisible index of 1 there. So 6 minus 1 is 5. So that's the final answer. Okay, and so now we've learned and revised product of powers. Okay, and quotient of powers. Now the third rule or law that we need to remember is what we call the power of powers. So this is when we have a raised to n raised to m. Okay, this is not the same as a raised to n times a raised to m. This is a raised to n times, a raised to n raised to m. Okay, and so the answer to this is a raised to n times m. So you multiply the indices, okay, this time. Now, if you have more than one variable, so suppose you have a raised to n, b raised to n raised to m, and that would be a raised to n times m, b raised to n times m. Okay, let's look at an example or examples. Okay, suppose we have a raised to 4, okay, raised to 3. So that's going to be a raised to 4 times 3. So that's a raised to 12. If you have more than one variable, you have a squared b cubed raised to 3, or cubed. So it's going to be a raised to 2 times 3, b raised to 3 times 3. It's going to be a raised to 6, b raised to 9. Okay. So you need to be careful. Okay. So you need to multiply when it involves power of powers. Suppose there's a numerical coefficient. Let's try something simple. We have quantity 2, a to the 4, b 6 squared. So it becomes 2 squared. Okay. Now remember that there's an invisible index of 1 there. So 1 times 2 is 2. So 2 squared. A raised to 4 times 2. B raised to 6 times 2. So that's going to be 2 squared is 4. 4a raised to 4 times 2 is 8. B raised to 6 times 2 is 12. So that's your final answer. Okay. Right. So that's power of powers. Another rule that we need to remember is when we have negative powers. Okay. So when we have negative power, suppose we have a raised to negative n, that is equal to 1 over a raised to n. So the index becomes positive now. So it's essentially the reciprocal with the reverse sign of the index. Okay, and so if you have a raised to negative 4, that is the same as a raised to 1 over a raised to 4. Okay, or vice versa. You have the converse of that. If you have 1 over a raised to 5, that is the same as a raised to negative 5. So the reverse works as well. Okay. So this is simple, and it's important because most of the time final answers would require only positive indices, so you don't want negative indices. Suppose you have, so let's use it in an example. So another example here. So we have, say 15, a raised to 4, b squared, c raised to 8, divided by 3, a squared, b raised to 6, c raised to 5. So we'd use the quotient of powers here, right? So 15 divided by 3 is 5. Okay. A raised to 4 minus 2 is 2. B raised to 2 minus 6 in this case, so that's 2 minus 6, okay, is negative 4. Okay, raised to C, B raised to negative 4, C raised to 8 minus 5 is 3. Okay, now so you can see you have a negative index there, so you can write it down as, just quickly just put it on the denominator. Works the same way, 5a squared c cubed over b to the 4. Okay, so but don't forget to remove the negative sign once you transfer it to the denominator. So that's the negative powers rule. Again, feel free to pause the video whenever you want, so you can take down notes or you can try out questions by referring to the discussions. Right, so fifth one is the 0 power. Okay, so any base that is raised to 0 is equal to 1. So that's very simple. So you have a raised to 0, that's equal to 1. B raised to 0, that's equal to 1. Right, so let's try it on several examples here. Okay, so let's try, right. Okay, let's work on this. So you have m raised to 5 times m raised to 3. So there is an application of product of powers again. So that's going to be m raised to 5 plus 3. So the answer is m raised to 8. The answer is m raised to 8. This one is quotient of power. So m raised to 8, I usually write it this way, divided by m raised to 2 or m squared. So it's going to be m raised to 8 minus 2. Okay, and that's going to be m raised to 6. So m raised to 6. Now be careful, you're not dividing the indices, okay? You are subtracting them. The third one for letter C is product of powers. So that's m raised to 3 times 2. So that's m raised to 6 as well. Right, that's simple enough. So we have a combination for the next one, right? So for number 2, again, you have an invisible index there. So that's technically, so that's product of powers there. So m raised to 9 plus 1 is 10, divided by m raised to 5. So that, this case, it's quotient of powers. So m raised to 10 minus 5. So that's m raised to 5. So that's your final answer. We'll skip number 3 because that's simple enough. Let's work with number 5. Okay, so for number 5, again, so you have a product of powers there. So s raised to 3 plus 4 is 7, divided by s squared. That's going to be s raised to 5, because 7 minus 2 is 5. So s raised to 5. Again, feel free to pause the video. Okay. So in this case, we have a negative index involved. Okay. So we have w raised to 3 or cubed times w minus 5, raised to 5, raised to negative 5. So you can work it out the same way. Okay. So you have w cubed times w raised to minus 5. You can follow the rule, so it's going to be w raised to 3 plus negative 5. Just use your rules for adding and subtracting integers. So 3 plus negative 5 is negative 2. So w raised to negative 2 but then you don't want a negative index, so you know that that's equal to 1 over w squared, following the negative power rule. So that's final answer is 1 over w squared. Okay, so unless specified, you can actually write that down, but most of the time it will require a positive index. Right, in this case, we have a raised to 4 divided by a raised to negative 2. So that's going to be a raised to 4 minus negative 2. So you have to be careful. Mind your integers. So that's 4 minus negative 2 is the same as 4 plus 2. So the answer is a raised to 6. Right. So all you need to do is really apply the laws of indices and then remember how to add and subtract, multiply, and divide numbers, positive or negative. Okay, if it's a calculator test, then that problem is solved. But if it's not a calculator test, then you have to do it mentally or manually. You can write down. Okay, so let's work on this. 7, 8, and 9. Right, so we have more than one variable here. So it's multiplication. So 2a cubed c cubed times 3a squared c. So we multiply the coefficient. So 2 times 3 is 6. A raised to 3 plus 2. C raised to 3 plus, there's an invisible 1 there, plus 1. The final answer is 6a raised to 5. C raised to 4. I almost wrote B there. Okay, so the final answer is 6a raised to 5, c raised to 4. Right? So that's pretty straightforward. You can even pause the video while I'm answering, and then you can work it out and see if you got it right. Right, next, this is division. So again, we just carry on with the coefficients. So 10 divided by 2 is 5. Next, it's going to be m raised to 5 minus 2, applying the quotient to power. And then n raised to 4 minus 1, invisible index there, or exponent. So the final answer is 5. M raised to 5 minus 2 is 3. And 4 minus 1 is 3. So final answer is 5 m cubed n cubed. And finally, this is power of powers. So that's 2 cubed m raised to, let's just, erase this. Okay. M raised to not adding anymore because this is power of power. So it's going to be 4 times 3. So 2 cubed is 2 times 2 times 2. Let me just write that down on the side. So that's 8. Okay, m raised to 4 times 3 is 12. So that's your final answer there. 8m raised to 12. Right. And so that's how you apply the laws of indices in simplifying expressions. Okay, so please make sure you write down notes on the laws of indices, include the examples, so you have something to refer to. Okay, feel free to pause the video at some point or go back to parts of it. Okay, so you can revise through it and you can listen to it again and again. And so let's look if we achieve the goal. So we use the laws of indices in simplifying algebraic expressions, which we did in this video. Okay, please work on the task provided to you. Stay safe and have fun learning maths. Bye bye.